be about solving rational equations. And if you hear strange noises from the background, it's fourth period. Okay. So just like on simplifying, you want to start with factoring each one. Obviously, this doesn't factor, nor does my pen write. This doesn't factor. Second term won't factor, but this last term that it equals over here is going to factor to what? What multiplies to be negative 88 that adds to be 3? Anybody? Luckily, it's x minus 8 and x plus 11, and that is very helpful. We do want these to match, so oftentimes you can use the other terms to help you with your factoring. Now, the nice thing about equations is, since I have two sides, I can do something to one side because I have another side to balance it out. So I'm going to do something to both sides. So I'm just going to completely eliminate the fractions. What would I have to multiply by so that I could eliminate all the fractions when I distribute? The common denominator. The common denominator, which is x minus 8 and x plus 11. So what I do, and you can have whatever system you want, is I write x plus 8. Sorry, that's x minus 8. X minus 8 and x plus 11 out here. Now, I'm distributing. I'm going to distribute this whole thing to each part. Okay, now I'm going to show my work very carefully this one time. After that, I will not show near as much work. I have 9x minus 8, and I'm going to multiply that by the x minus 8, x plus 11, right? Then I'm going to take my plus 2 over x plus 11 and multiply it times the same thing, x minus 8, x plus 11 equals, then I'm going to take my last term, 6 over x minus 8, x plus 11, and multiply it by my x minus 8, x plus 11. That didn't work out very well. Let's try again. You can, if you'd like. Sure, put a 1 underneath all of them. X minus 8, x plus 11. Didn't work out much better. But anyway. Okay. So, the nice thing, yeah, you can put a 1 under here, is now that cancels. This will be the last time I show my work that completely. You should be able to visualize what's going to happen and what you would have left. So when I cancel these, I get my 9x plus 11 plus, what's going to go in the next spot? 2x minus 8 equals, and the nice thing over there on the right after the equal sign is everything cancels. So I just get 6. So now I don't have any fractions left, and that makes this much better. From here, what do you think we ought to do next? So we're going to have 9x plus 99 plus 2x minus 16 equals 6. We're going to collect terms. The 9 and the 2 are going to give me 11x. The 99 take away 16 is going to give me what? 83 equals 6. Now it's just a two-step equation. 11x equals negative 77 divided by 11. X equals negative 7. Okay. Does anybody remember these from last year and remember having to ask yourself, is this answer okay? Whoops. Don't know where that came from. Has something to do with the original question. Would any value of x make the original question not work? What would it be? And we call those our excluded values. Okay, I say EV for short. Our excluded values would be, and I put it this way, x cannot equal 8, because if it did, this first fraction would be undefined, and I can't do undefined plus anything, wouldn't work. The second fraction, x cannot equal negative 11. So those are my excluded values, which they don't really make any difference unless your answer ends up being one of those. Is my answer one of my excluded values? No, I have no problem. So this is my final answer. The x equals negative 7 is my final answer. Questions? Wouldn't it be nice if they all stayed that easy? Let's go to the next one. The next one, actually, I'm going to go out of order. We're going to go to number 3, and I will come back to number 2 later if we have time. So, what? So example 3, everybody go ahead. Oopsie. Everybody go ahead and write example 3 down. In case I don't get to it with y'all 4th period, example 2 is really easy. Okay, square root of 2x minus 1 plus 3x over okay, so this one's actually easier, but it just looks a little scarier. Do you remember having the expression that looks like this? If I didn't have the equal 0, we had those. But actually, it turns out kind of nice, because on this one, if I'm getting rid of my fractions, I can just multiply by the square root of 2x minus 1. Correct? I can multiply by the square root of 2x minus 1. When I do that, now I'm not going to show my work as meticulous this time. I'm going to distribute to here, here, and here. What happens when I do my first distribution of the square root of 2x minus 1 times the square root of 2x minus 1? It's just 2x minus 1. Plus, what happens with the next distribute? The numerator, the denominator cancels, and so I just have my 3x, and then 0 times anything is 0. That makes it nice. So this ends up nice and easy. 3x, sorry, let's go with 5x, minus 1 equals 0. 5x equals 1. X equals a fifth. Any questions about that? We got to check our excluded value, don't we? We've got to check our excluded. Okay, I'm going to rewrite that. That is 1/5, but it just looked funny. Now, that is most likely our answer, but we have to check our excluded value. And this is a little bit trickier this time on our excluded value. Okay, so let's talk about our excluded value. Let's go back and look at the original. What would make this undefined? There's more than one thing this time. Look at this first term right here. What might make this? Is there anything that would make that undefined? It needs to stay positive. So if it were negative, if the junk under here were negative, or the argument, the real word for the junk is argument. If the argument here were negative, then I would be taking the square root of a negative, which is imaginary, and that doesn't get me a real solution. I'm looking for the real solutions. So we need to keep, whoopsie, we need to keep 2x, and since I always say what it can't be. My excluded value is what I can't have. So this stuff can't be negative. So I'm going to say 2x minus 1 can't be negative. So 2x minus 1, if it's less than 0, we got an issue, right? If 2x minus 1 is less than 0, we have a problem. It needs to be excluded. Are you with me? Okay? Because a lot of times when we do this in a different setting, we would have said 2x minus 1 has to be greater than 0. But now I'm talking about what it can't be, and it can't be negative. So I'm saying 2x minus 1, it would be negative when all this stuff is less than 0. Now, what about this fraction? What would make this undefined? Same thing? There's only one other problem here. It can't be 0 either. So go ahead and put your, it also cannot equal 0. Not only can it not be less than 0, it also can't equal 0, because if the denominator of this fraction became 0, another issue. Yes, ma'am. Then you say no solution. So you would say no solution. So let's see if that actually happens here. So let's look. This is pretty simple to solve. 2x is less than or equal to 1. So now you have to make sure your brain is listening or understanding this. All the values that are smaller than or equal to a half are excluded. All the values that are smaller than or equal to a half are excluded. Is ours excluded? So we're going to put no solution. Let's just double check and prove it to ourselves, because sometimes that's kind of yucky in your head, backwards in your head. So put in your calculator 2 times 1/5 minus 1. 2 times 1/5 minus 1. Does it end up being negative? It does end up being negative. So the only answer that got produced would give me a negative under the radical, and therefore this would have no solution. There is no real value of x. Now there's maybe an imaginary value, but there's no real value of x that will make the left side equal to 0, which is the right side. You with me? Okay. We're just going to do, actually, I'm going to pause right there. We're going to finish out with example 4, and actually then I'll go back and do example 2, although it's very easy. You may not need to watch that one. Example 3 looks very difficult, but, and it kind of is. So I would definitely pay attention to this one. If you'll notice on some of your sheets that I handed you out, example 4 actually had a plus right here and here. I have switched that now to a minus. It works better with this problem for that to be a minus. So switch your question to be 4x squared minus 3 if that's not what you had. So here we go. Just like we've been doing, we're going to take the equation as is. In fact, I think I'm just going to copy mine again. And bring it down here. And just like on all the other equations, I'm going to multiply by the common denominator. The common denominator here is the square root 4x squared minus 3. Okay, I'm not going to show my work completely. When I multiply 4x squared minus 3 to the first term, which is this term here, I get my 3e to the power of 3x, and this multiplies times itself, so it's 4x squared minus 3 squared. Plus, this term just cancels out, and so we have our 4xe to the power of 3x equals, and of course, times 0 would just be 0. So now I have an equation with no fractions, which makes it a little bit nicer. You know what? As always, I didn't catch myself. That's not squared. It's just close parentheses. No squared there, I apologize. The square root times the square root roots cancel, and so it's just the argument. The argument is the part underneath the radical. So 4x squared minus 3 would be there without the squared that I accidentally wrote. Okay, now let's distribute, and I'm going to get 3e to the power of 3x times 4x squared minus 3e to the power of 3x times 3 plus 4x e to the power of 3x equals 0. Okay, you don't actually have to show this much work. You probably could have done this, skipped the step that I just did. So this would be 12, because 4 times 3 is 12, e to the power of 3x x squared minus 9 e to the power of 3x plus 4x e to the power of 3x equals 0. Now that looks really bad. But if you notice, they all have a common factor of e to the power of 3x. So I'm going to factor out e to the power of 3x. When I factor that out, I end up with 12x squared here minus 9 plus 4x equals 0. Now that looks a little bit better. Just like any other question, when we have two parts that are being multiplied together and they equal 0, the product of these two equals 0. So each part should be set equal to 0. Now, as I set this part equal to 0, I'm going to rearrange the order to put it in descending order. So it's going to be 12x squared plus 4x minus 9 equals 0. Now we just have two small equations that don't look near as hard. How would I factor this one here on the left? Well, it's got an e, so I'm going to take the natural log of both sides. Hopefully you already know what's going to happen. This would cancel, so 3x equals the natural log of 0, but logs are not defined at 0, so this would be undefined. So this part's out. That x will not produce a value that could be used for this equation. So let's look over here. On this one, if you're doing this with your calculator, we've been doing this in our calculator. Let's wait for my calculator to pop up. You would put the equation in y1 and put 0 in y2. So let's clear this out. The equation was 12x squared plus 4x plus 9. Make sure that's what I had. Let's go back. Let's see. No, it's minus 9, isn't it? Minus 9. Let me go back to my calculator and get minus 9. Sorry. Minus 9. And now let's put into y2, let's put 0. Let's graph and see if by chance the window's okay. Oh yeah, it's not bad at all. Okay, so I have two answers. We're going to intersect. And my first answer is going to be 0.715. Let's go record that down over here. So x equals 0.715. Okay, let's go back to the calculator and find the other one. We do the same way. Calculate, intersect. This time I'm going to put my cursor a little over closer to the negative side. And I have negative 1.049. Negative 1.049. Let's record that. So there's the two decimal versions. Now we have to see which one actually works. Which one actually works? Let's see. If they both work. Maybe they both work, maybe one works. So we're going to have to check our excluded values. Let's go back up and look at the original question. The original question, which I think I'll copy again. Let's do this. Oops. Let's pull this guy down to the bottom. We're looking for our excluded value now. Let's do this. So what would excluded value? We know that the argument under the square root, the 4x squared minus 3, we don't want that to be negative because we don't know how to take the square root of negative. So we're going to exclude all the values in which this would be negative. So we're going to exclude the ones that are less than 0. We can take the square root of 0, right? It is 0. So we want, if this thing were to go negative, so if 4x squared minus 3 were to get less than 0, it would be negative, and we have to exclude those values. But also look right here. Look at that denominator. What is it? Denominator, we know a denominator cannot equal 0. So not only do we have to exclude the negatives so that we don't take the square root of a negative, we also have to exclude 0 itself. So we're going to come back and put the or equal to sign there, because if the argument of 4x squared minus 3 did equal 0, this fraction right here would end up being undefined, and we can't let that happen either. So these are what we're going to have to exclude. The 4x squared minus 3, when that argument is less than or equal to 0, we will have to exclude those values. So let's solve. This is pretty easy. Divide by 4. So x squared is less than or equal to 3/4. Let's square root both sides. So x is less than or equal to. Now, be careful with this. What is the square root of 3/4? So I'm going to have to pop that in my calculator. The square root of 3/4 is 0.866. But also don't forget you need a plus and a minus because you took the square root of both sides. So also don't forget, when you put a negative with an inequality, the inequality has to turn to face the other way. So this would be negative 0.866. So we have to exclude the values that are smaller than 0.866 but larger than negative 0.866. Just to give you a visual on that, on a number line, if this is 0, negative 1, and 1, negative 0.866 would be about here. Let's change colors. Negative 0.866 would be about here. Positive 0.866 would be about here. So all the numbers bigger than the negative, but smaller than the positive. So all of these numbers in here have to be excluded. We cannot use the numbers in there. Let's go back and look at the answers that we got. We got 0.715. Where would that be on my number line? That would be right here. Change colors again. 0.715 is one of our answers we got. The other answer we got was negative 1.049, which would be about here, negative 1.049. Clearly, you can tell that this number is landing within our excluded values. So let's go back up. This is out. This one's the keeper. We're going to keep that one. Now, you might be asked to do this using the quadratic formula. If I ask you for an exact answer for the value of x, you would need to use the quadratic formula. Why don't you pause the video real quick and see if you can do the quadratic formula on that. I will write the answer right here. The quadratic answer for this one is, go ahead and pause it, and then come back and you can see this answer. Okay, that might be something you're asked to do, is to put that in the quadratic formula. Reducing the radical is the hardest part there. Reducing the radical would be the hard part. Okay, let's go back to number 2, and then you will be ready to do your homework, whatever parts you want to on the homework. Let's go with example 2. Example 2 says x minus 6 over x minus 1 over x plus 9 equals 9 over x squared plus 9x. No changes to make here. As you can tell, there's nothing factorable here, nor is there anything factorable here. But on this last fraction, we're going to factor out an x. So my common denominator is, of course, x plus 9. So let's multiply everything we see by x plus 9, which is our common denominator. As you distribute to here, and to here. Hopefully you're getting good at that. On this one, we could tell that the x would cancel with the x, and so we'd have x minus 6 and x plus 9. Minus here, the x plus 9 would cancel with the x plus 9, so it's 1 times x, which is just x. And on the last one, the whole denominator cancels, and so we just have our numerator of 9. From here, we need to FOIL. Foiling this out, pause if I go too fast, would give you x squared plus 3x minus 54 minus x equals 9. Combining like terms, it's going to give you x squared plus 2x minus 54 equals 9. Subtract the 9 over. We're going to have x squared plus 2x minus 63 equaling 0. This is factorable to x. Pause if you need to. What multiplies to be negative 63, that adds to be 2. We're going to factor to x minus 7 and x plus 9. Setting each one equal to 0 would give us x equals 7 and x equals negative 9. At this point, you need to go back up and check your excluded values. It looks like negative 9 is an excluded value. Let me do this real quick. Excluded values would be x equals 0. That comes from this guy. And x equals negative 9 is also excluded because if that part equals 0, it would make our equation undefined. So the negative 9 is out. The positive 7 stays. Okay, you are free to do your homework.